So, starting into the truly differential calculus first half of the year. So we read the notation for the derivative. F prime of x, all of this is the derivative. Now, the only way I can think of like a legit definition, again, this is called Leibniz notation too. It means, it all means the same. Take the derivative. Now, when I am thinking of what in the world does a derivative mean, there's a couple ways to think of it. It is a rate of change at one specific x value. So if I say f prime of a, I mean the rate of change of the function f of x at one particular value. We have done rates of change in pre-calc. It was called the average rate of change. Does anybody know what the average rate of change was the same as? It is on an interval for x's, x going from a to b. Anybody remember that we did it like in 1 second, or maybe, I say 1 second, 15 minutes of one day, probably, because it is equal to something you did in Algebra 1 and Algebra 2. The average rate of change of a function from x equals a to x equals b. Any recollection at all? It's actually the same as the slope of the line, okay? It is y2 minus y1, or the calculus way, f of b minus f of a over b minus a. That's what the average rate of change is. But this is actually called the instantaneous rate of change. Many times, they will not use the word instantaneous. They'll just say, find the rate of change of f at one value. What should that trigger in your mind? The derivative. Find the derivative. If they say, what's the rate of change on an interval? Think in your head, find the regular old slope. Another thought process about the derivative, though, is that it is equal to the slope of the tangent line. So draw yourself a little graph. This is like my f of x graph that I draw. If somebody says just draw a function, that's almost always like what I draw. Don't know why, but I just like my cubic. So, if I were to think of geometry, what did the tangent line, or what was your thought process if I said find the tangent line to the circle at that point? You're afraid of answering incorrectly. Nobody can remember geometry?
Learn geometry. That was COVID.
COVID year.
And we had Spigot, and she didn't teach us anything.
That is not true.
It is true.
I'm going to bring Lori over here.
Please don't.
Guys, when I taught geometry, the idea of a tangent line, I just said it's just a line that intersects that circle in exactly one point. So there could be tangent lines all over the circle. And in geometry, someone at Burton remembered a lot because they're like, yeah, it's perpendicular. Any tangent line is actually perpendicular to the radius at the point of tangency right there. That's just, and there were other theorems, like if you had two tangent lines from a point, they had to be equal. The distance from that point to that point of tangency had to be equal. There was that theorem that if you had, oh, does anybody know what the line is that goes through a chord? Starts with an S. I didn't hear. A segment of a circle is a weird thing. The segment is called a chord, right? The segment that has endpoints right there. But what's the line that contains that? Starts with an S. It is SEC. The secant line. And again, why, with all the combinations of letters to make words, would someone choose to use tangent and secant again to mean something completely opposite from, trig, when we had the angle and we had the opposite over adjacent is the tangent, right? The tangent of theta is A over B. The secant of theta is what? C over hypotenuse over adjacent, yeah. So, again, why? I don't know. I don't have a clue what. They're not related to each other, I don't think. I can't relate them to each other. But the idea of a tangent line to a just regular graph is essentially kind of that same thought process. It's a line that intersects at least locally at just that one point. So it's the idea of grazing, right? What do I notice about this point up there? What would you say the slope of that tangent line is definitely? What's the slope of a line this way? 0.
Yeah.
What about down here at the bottom?
0.
Yeah. There's some cool things that we have when we have 0 slopes. Rise.
No rise over
It doesn't rise any, it only runs. But somebody tell me something about on the left side of this maximum point right there. All of these slopes look like they're what? Positive or negative?
Negative. Positive.
Rising up to the right is positive. On this side, though, what would they be? Negative. On this side again, what would they be? Yeah. So there is an idea with graphing that we use positives and negative slopes a lot. And those happen to be the slopes of the tangent lines. Now, I got to be honest, the idea of grazing this over here is not hard. But like, look on this side. I mean, all right, I graze it, but then I cross over the curve pretty quickly. It literally just means in a little small area around there, it only intersects it at that one spot, okay? Is that good to think about tangent lines? The idea of a tangent is that it only crosses at one time with the circles, but it turns out, I mean, this on the left side, this doesn't hit it again, but on the right side, it kind of crosses down over the graph. We're really just talking about in a small area around there. Because even this one that's horizontal, that has a slope of 0, if I kept that line going, isn't it going to intersect the curve again over here? So that's what I'm saying is just locally, it barely hits the graph at that one point. Can you close your laptop, please? So that's the idea of a tangent line. Now we have to figure out how, yeah.
Are you imagining a circle with this graph? Can you have a line like a tangent that goes straight through? That could be-
All right, here, I'm not, like, here's an issue. How about if I have an absolute value graph? Turns out that the tangent line to all of these points is actually that line. Yeah. And the tangent line of all of these points is actually that line. So that idea of grazing the graph is only if it's a curved graph, kind of.
I mean, like if it's like a straight line,
If I had the straight line,
like so this curved line, right?
mhm,
This intersects like this.
straight up and down there, no. It has to go like towards the curve. So, yeah, there's only one tangent line at any given point, and it's the one that is kind of going with the slopes of the line.
The one that's closest to being parallel.
It's the one that is closest to being parallel to that graph. Yeah. That's a good thought. But the weird part is that if I have a line, what does this look like the slope is? 1/2? Rise 1, run 2. The slopes of any point on that line is what?
1/2.
1/2.
Yeah.
Exactly. On this one, on the left side of 2, it looks like it might be negative what? 3/2? Negative 3/2? But on the right side, it looks like it is positive 3/2, doesn't it? Rise 3, run 2. So lines are a little bit different, but they're still easier. Now, what our dilemma is, and I think I'm going to draw like just a little teeny curved part of a random function. And I want to make sure it's plenty curved because I want us to be able to. This is the point A. I want to estimate what the slope of the tangent line, bless you, what the slope of the tangent line is at that A. Now, I could literally give you a graph and say, what is the slope of that tangent line? And if I draw you a grid really carefully, I mean, that's pretty daggone close to 1, isn't it? Rise 1, run 1 at that particular point. I don't want you to just estimate at this particular point because your A may be at a different place on your curve, right? But I want to come over here and I want to call this random point X. Give me the coordinates of this point, if this is the function f of x. This is A, comma, what? I have not given you any units at all. I've only given you an A and an X, and the function is f of x. A, comma, f of A. What is this? What are the coordinates of this point?
X, comma, X.
F of x. There we go. So, if I were to ask you, what is the slope of that secant line connecting those 2 points? Could you give it to me? The slope of the secant line? The slope of any line is y2 minus y1 over x2 minus x1. So would you agree? y2 minus y1 over x2 minus x1. That is the slope of the secant line connecting those two, right? is that a good estimate for that one I drew? Does that look like it's a good estimate for the slope of the tangent? Well, what if I moved the x right here, though? What about that estimate? Is that getting closer to the slope of our tangent line?
Oh, yeah.
The tangent line is in green. The tangent line is the one that barely grazes the graph in that one exact spot. Does that make sense?
Is it only going through the A?
It is only going through the A, f of A. So I have now moved my x, and it looks like my secant line is getting closer, doesn't it? I moved it here. It's not very close. I moved it here. It's even closer. Where else could I really move it? Closer and closer to the what? Guys, what is the idea of closer and closer?
To get close.
We just, in all of chapter 2,
Really?
we were talking about what's? Find a limit.
Oh, my goodness.
As our x gets closer and closer to what?
Why? A? A? Why?
Where's the y on the page? That's my question. If you said f of x, I would not have put my hand on my head. But there was no y on the page. I'm sorry. So, guys, this actually is the exact slope of that tangent line. If my x gets closer and closer and lines up right on the A, I have the exact slope of the tangent line at A. This is called, from the book, the alternate definition of f prime of A. It is
Prime of A.
f prime means the derivative at x equals A. The derivative of f at x equals A. Someone asked last class, well, could the x have been on the other side of A? Sure enough, couldn't it? If we get closer and closer to A, that slope is getting closer and closer to the green line, isn't it? The idea of limits was a setup for derivatives. All right, no, you say that, but once we get through today's lesson, we are going to have shortcuts, and you're gonna like groan because they're so much easier. Yeah.
Like, what does, like, F prime, like, specifically mean?
The derivative of f with respect to x, actually. So, but in this case, when I say f prime of A, the x value is what? A. So it is on the graph, it is the slope of the tangent right there at A, f of A. Does that make sense? Or it's the instantaneous rate of change at x equals A. So, we have one method for finding a derivative, and let's just say f of x equals x squared plus 1. Find f prime of 2. What I would suggest for your first few derivatives that you do by hand like this with limits, I would suggest, this is what I did, if the directions say use the alternative definition, make your x approach what? 2. And then put the formula, if you want to remind yourselves what we're actually plugging in. And You won't have to study the formulas ahead, again, because you'll have written them down 16 times, right? So, and this alternative one, you won't write down a bunch, but. So what do we replace f of x with in the formula? The x squared plus 1. Easy peasy. What will we replace f of 2 with? 2 squared plus 1 is 5. I replace the x with the 2, right? I'm reminding myself I still need to replace the x with the 2, right? I'm seeing on the top, 1 minus 5 is what? -4. So now, what can we do to the top? Factor that thing. And what cancels? By the way, if we'd plugged in a 2, we would have gotten a 0 over 0, so we knew we had to keep going, right? But now, we have a 1 on the bottom. Replace that x with the 2, and what do you see?
4.
So it looks like I may be willing to, if we have some of these, I may be willing to look back at your chapter 2 paper. And if there's a few more points I can give you, I will, if you have done the limit definitions. The problem is I'm only giving you 2 problems that you have to do this is the long method. The short method is going to take you on this one, it would have taken you about 15 seconds. So,
So, why do we have to learn the long method if there's, the easy method?
Just the way calculus is.
We'll never use this method if there's an easier method, so why do we need to learn
All right, here's one thing. On the AP exam, they may give you a problem that doesn't say find the derivative, but they'll give you a problem that looks like this, and they'll say find that limit or whatever, and you'll be like, oh, there's my function. I can take 10 seconds to find the derivative and then plug in, and it takes me 15 seconds, okay? And you don't have to do the messy work. And in fact, I showed you the alternative definition because for whatever reason, to me, it makes the most sense in terms of a drawing, okay, a graph. But the initial, the legit limit definition of derivative has either a delta x in it or an h, okay? So I'll draw my little curve. I'll draw my A. But instead of calling that next point x, f of x, they're going to call this A plus h, or A plus delta x. Because delta x means a change in x value, okay? I don't know when they changed delta x to h. When I was in school, they always used delta x's. I hadn't seen an h until I started teaching calculus here. But, so, if I now use this new notation, this is still the point A, f of A, isn't it? Correct? But this one, what's the x value? A plus h. And what's the y value? Everybody agree with that? I'm changing a terminology. And so this distance right here is my h, or delta x value. So if I'm still trying to find the slope of the tangent at A with my new terminology and limits, what are we going to have to do to get to line up with the slope of the tangent? What is going to have to happen in this terminology? Before, we said the x, everybody with me? Before we said that the x was approaching a. Now what are we going to be saying? A plus h is approaching a. Okay. But what, from this drawing that I just did, the distance from a to a plus h is delta x or h. What is happening to that delta x or the h? The distance is actually going to closer and closer to if I give this, hang on, I'm trying to make you, you're going to get this. Right now, 1, 2, my a is like at 2. My a plus h is at 4. What is happening as I move that point to the length of delta x or h? Shrinking and getting closer to what?
A.
No! It starts out here as 2 units, then it goes to 1 unit. It is approaching 0. What did you say? Oh, what? I don't get it at all. Is that what you just said? This is why I believe I think the alternative form is easier to think of the x as approaching a. None of y'all had any trouble thinking x was approaching a, right? It's a little bit weirder to think h is approaching 0 or delta x is approaching 0, isn't it? Everybody good with that now, though? If that a plus h is approaching a, the h is approaching 0, right? All right. So we're still doing a slope. So what's the top? H minus f of a all over a plus h minus a. So what does that turn out to be? F of a plus h minus f of a all over what? H. Or the old school version, or you'll see it, they throw it down sometimes on the AP exam, delta x. Same thing. So this is the actual limit definition for derivative at a specific value. And I can't stop here. If I want, this is like the function version of derivatives. So like if I ask you in that x squared plus 1 function, if I ask you to find f prime of -2, -1, 0, and 2. Well, I don't want to do this thing 4 times, right? So use this formula and you can just plug and chug at the end. I'll show you. Well, just to prove that they're the same. What was that function we used? X squared plus 1. And we found f prime of what? 2. So let's apply this formula. When they say use the limit definition, this is the formula you got to use anyway. F of 2 plus h minus f of 2 all over h, right? So now applying it looks very different than the alternative definition. This is where I've hit this already in pre-calc. We're going over these like function notations, and what do I mean by finding f of 2 plus h? Replace any x's with what? Two plus h. 2 plus h squared plus 1 minus, use parentheses liberally, f of 2, you might not need it. 2 squared is 4 plus 1, we already did it, right? But now we have to distribute, FOIL it out, right? What is 1 minus 5? Negative 4. Oh, I got a positive 4 there and a negative 4. Everything else has what in it? H. So guys, we have already done a butt ton of these limits, haven't we? We just didn't know what we were finding. What is 4 plus 0?
Oh.
Is that what we got over here? Yes, it is. The alternative definition way and the regular definition way. But, so the first formula works. But again, what if I said I didn't want just f prime of 2? I wanted f prime of negative 1, f prime of 0, f prime of positive 1. Well, I don't want to do this 3 more times, do you?
No.
So this is where we do the formula. X squared plus 1, right? So let's do the limit definition formula. I'm telling you, this is the way I memorized all my formulas. I wrote them out the first few times I used them so I wouldn't forget them. I'm rewriting it. Do you think I need to write this down for me? No, I've written it down at least 500 times. What is f of x plus h, though? Replace the x with an x plus h squared plus 1. Everybody agree with that? The cloud part is that cloud. There's a minus sign. Here is where I implore you to always just throw in parentheses because you're going to forget them and forget to distribute a negative. Yeah.
Where did you get the x plus h squared plus 1 from?
I replaced any x with a what?
X squared plus 1.
No. I replaced the x in the function with an x plus h. If I said find f of zebra, what would you say? What is f of zebra?
Zebra.
Zebra squared plus 1. What's f of elephant?
Elephant plus.
Elephant squared plus 1. What's f of a plus b? A plus b, quantity squared plus 1. That is what any of these formulas, whether it's the alternative one or this one, whatever is in the parentheses, replace any x's. If there's 4 x's in it, guess what? We got to put it in 4 different times, right? I won't do that to you, but what do I put in place of this rectangle?
Negative 1, 0, and 1.
This is a plain old f of x.
X squared plus 1.
X squared plus 1, yeah. Again, we have been doing some of this work already. We even did it on that test, only the h was a delta x. What is x plus h quantity squared? 2xh
Plus 8. What? 2HX. 2XH. Where'd you get that from?
x plus h. times x plus h. X squared. XH plus another XH is 2XH. Plus 1. Distribute. You see why I always put parentheses around here? I gotta distribute the negative. And then just like it did on that one problem we did on the calculator page, the x's go away, the 1's go away, and everything else has a what in it? An h that can be factored out. There we go. H's are gone. Now what can I replace my remaining h with? 0. What is 2x plus 0? 2x plus 0 is 2x. So now I have the function for the derivative. I can find f prime of anything. F prime of 1, f prime of 0, f prime of negative 1, f prime of zebra.
Zebra.
What is f prime of negative 1?
-2.
F prime of 0,
0.
f prime of 1,
2.
f prime of zebra.
2 zebra.
2 zebra. I don't know why I always pull out poor zebra. I saw a little thing that I was watching with my grandson, and they were at some zoo, and I did not know that horses could breed with with zebras. And
Wait, there could be a zebra.
I forgot what they call it. A zorse. I think they call it a zorse. Or a zerse. I don't. Are you looking it up? Did you look it up?
I can look it up. What's it called? A source?
Is there such a thing as a zebra horse? Whatever.
Oh my gosh!
What's it called?
A zorse.
ZORSE.
No, wait, sorry. Z-horse. Like,
A Z O Z
Z-horse?
a zorse. Anyway, so let me do a couple of more examples, like you weren't finished? Oh, okay.
It smells like spoiled milk. Because that's what it is. Smell my notebook. Don't smell it.
All right.
She spilled milk on it. It's moldy.
All right, find g prime of 3 if g of x equals that, and this is not the alternative definition, just using the limit definition. So, what shall we write down for our formula? I'll start you. Limit as h approaches 0. It's because y'all are talking about a notebook that smells like throw up.
She spilled milk on it.
I
It's
know it.
moldy.
F of A,
Or g of,
G of
in this case, 3 plus
H,
minus,
G of A. Wait,
your a is 3. Hey, write down, you're welcome to write down the a's. That gets it to your brain one more time, right? What do we put for g of 3 plus h?
3x squared minus x plus 1.
3 of what?
3x squared minus x plus 1? Why not?
Each of the x's is replaced with what?
8. 3 plus 8.
3 plus h.
3
3 plus h squared minus 3 plus h plus 1.
This is the cloud. Everybody,
Yes, that's.
you should have gotten this in pre-calc. This is one of those that stumps people in pre-calc too. It is just function notation. If I ask you for what is G of zebra, what do you say? 3, you say 3 zebra squared minus zebra plus 1.
That's a bit aggressive, folks. Me, so
If I ask you what is G of 99, what do you say? 3 times 99 squared minus 99 plus 1. G of 3 plus h. Use parentheses in every place you see an x, replace it with a 3 plus h. Then we have a minus sign. Then you must put in parentheses. Well, maybe you wouldn't have to, but if you can plug it in with your head. But 3 times 3 squared minus 3 plus 1. Why are there all those 3's?
I don't.
Because I'm asking you for G prime of 3, and there was already 1 3 already in there. Sorry.
Someone just likes threes.
Somebody just likes
So
3's.
3 times 3 squared minus 3 plus 1. Does the 3 in the front go to all of that?
The 3 in the front only goes with the 3 that's squared, because there's no
But there's 2
parentheses.
3's. It goes with the 3 plus h squared.
Are you talking about this one?
No.
This
Second,
one
Yeah.
only goes with the 9. This one is 27 minus 3.
But why doesn't the 3 go to the whole thing? But why
Because there's no parentheses.
3 times 3 squared.
It's not, it is not this. If it was that, then yes, it would have gone with all of them, but it doesn't. It's only with the x that's squared right beside it.
No, I'm saying the 3 from the G of 3.
That 3, one more time, G of 99 replaced every single x with what?
99.
G of 3 replaces all of those x's with 3.
Oh,
Light bulb,
okay,
good.
I got you now.
27 minus 3 is 24, plus 1 is 25. Can you FOIL out the 3 plus h squared, I hope? 9 plus 6h plus h squared. Distribute 27. 3 times 6 is 18. Now it's just an issue with algebra. Can you be consistent with your algebra? What do we have with 20? What is 27 minus 3?
24.
What is 1 minus 25?
Negative.
Negative 24. All of those go out to 0, correct? What is 18h minus h? 17h plus 3h squared. Well, guys, we're down to all h's in the top, right? Are we okay factoring it out on top? That now cancels. Am I ready to replace that h with a 0? Shoo. Scared me. I thought we'd gotten the wrong answer. All right. One example that's gonna take us, what if I ask you to find f prime of x? Give me the formula. Send it to your brain one more time. F of x plus h. Remember, f prime of x, just the front. Minus x over
X plus H? Oh,
H.
just kidding.
So, this one is going to be the hardest you'll see, I believe. Maybe not. But what is f of x plus h? I'm replacing that x with, so I put a cube. I'm replacing that x also with an x plus h. This is just for the cloud. Does everybody follow? That's what goes into the cloud. Minus what goes into the parentheses.
Cube, X cubed plus 2.
There we go. I'm simply rewriting the function because that's what f of x is, just the function, right?
Yes.
This is the part that ain't easy. Pascal makes it.
Oh, no,
Oh,
Pascal. Oh, no.
It makes it easy.
I didn't
I
get
never
it.
understood this triangle.
Bro, I don't remember anything about Pascal. I don't remember learning that. I don't remember. We didn't learn it.
Thank you. A new person who listened to me and didn't have me last year. Funny. I actually do show you some things.
I remember.
Pascal's triangle, 1, 3, 3, 1. Review. The first one starts at the highest power, right? Then it goes down until it goes away. The second variable starts off.
I'm lost already. I don't get what you mean where it goes away.
I mean, are you serious? You don't know what goes away means?
No, like I do, but
I mean, I'm not being ugly. I'm just
like, what's
asking.
going away?
The powers. The power starts out at the highest, 3. Then it goes down to what?
2,
Then it goes down to what?
nothing.
1. Then it goes down to the 0 power. 0 to the 0 power is what? 1.
Why don't the H's
It does, it starts from the
contribute to
opposite
The
side.
H's start out at 0
And get bigger.
and get bigger.
that? Okay.
That's how it is. Distribute my 2. Distribute my negative sign. You are welcome. The highest I'll give you is a 3rd power. You are welcome to just FOIL it out and keep distributing if you're not good with Pascal. Pascal is just another tool to put in your tool belt if you ever need to take a binomial to higher powers. Yeah.
Can you like explain how Pascal's triangle, like how it helps us achieve that? Cause I don't remember learning.
Each of the, first of all, you start with 1 and end with 1. You know how to form Pascal's triangle, correct?
Yeah.
Okay. These are coefficients. Coefficient is 1, 3, 3, 1. The powers of the first term start at the highest, go down by 1 each term, down to 0. The second one starts off at 0, h to the 0 is 1, and then h to the first squared, and that's the last.
But like,
It's just a trick to take a binomial to a higher power. If it was to the fourth power, guys, what would the x's have been?
4.
X to the fourth, x cubed, x squared, x to the first, and then no x's. H would have been fourth, right?
Yeah.
Then we'd have had 0 h's, h to the first, h squared, h cubed, h to the fourth. All right. Does that, you follow at least how to work it? I am only going to go up to cubics. I'm not going to make you take it to the fifth. But when I was in school, we had to go up to the fifth and sixth power. Pascal was my friend at that point. I know. So cancel out everything you can cancel out. Everything else should be left with what in them?
H.
H's.
Yeah.
Factor that H out. By the way, if it doesn't cancel out, then you've done something wrong. So now the H's are gone. And now we're ready to replace any remaining H with the what?
0.
Those are gone. Are you seeing 3x squared plus 2? Okay,
That's the answer.
that's the answer.
So, like, how did you know to use Pascal?
Well, trying to remember. I guess I learned it in my pre-calc class. I guess that's what I did. Because
What in the problem is like, oh, I can use Pascal?
When it's to the.
a higher power. Right, just watch. You don't have to copy this down because you know I'll write like 10 times faster than you.
Wow, are you saying I'm slow?
I want to find y prime. What does it equal? The limit as h approaches 0 of y of x plus h minus y of x all over.
H.
I need to go not only to the fifth power, but also to the fourth power. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Literally, the first one starts off at the fifth power, right? Then use those coefficients. X to the fourth h plus 10x cubed h squared. Call them out now. 10
10x squared h cubed
plus 5x
5x
h to the
to the
fourth plus
plus h to the fifth.
nice. All of that was for this one. Uh-oh, I got a minus 6 times a bunch of stuff. But it's only to the fourth. So this is x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth. Whew. Minus parentheses x to the fifth minus 6x to the fourth.
How might all of this be easy? Or
Oh, I'm going to tell you the answer is 5x to the fourth minus 24x cubed. That's the answer. All right. So, distribute the 6.
That is when you cry.
X to the fifth plus 5x to the fourth h plus 10x cubed h squared plus 10x squared h cubed plus 5x h to the fourth plus h to the fifth minus 6x to the fourth minus 24x cubed h I distribute the 6 to each of those, minus 36, x squared, h squared, minus 4 times 6, 24, x h cubed, minus 6h to the 4th, minus x squared, plus 6x to the 4th. Everybody agree with that distributing? Now, x to the 5th, I wrote that as a square, but it's x to the 5th, gone. 6x to the 4th, gone. Every other thing has a what in it? Factor. 5x to the 4th plus 10x cubed h plus 10x squared h squared plus 5x h cubed plus h to the 4th minus 24x cubed, h was gone, right? Minus 36x squared h minus 24x h squared minus 6h cubed all over h. H's are gone. Replace all of the other h's with what?
0.
This one is left. Gone, 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 gone,
24. That's it.
gone, gone, gone. Isn't that what I said the answer was?
How'd you know that was the answer?
We'll look at it next time,
I
next
will look at it
class.
today.
5 minutes left.
So that I know how to do it easier.
Oh, what's the assignment?
One last thing. How much time we got? 5 minutes? What, I'm just gonna take one of the ones we just did, that, what did we figure out G prime of 3 was? 17?
Yes.
All right, and the G of X function was 3x squared minus x plus 1. And we went through all the rigmarole. What if I ask you to do one extra step and write the equation of the tangent line? What is the equation of a line? Go back to algebra. Point slope. Y equals mx plus b is 1. Y minus y1 equals slope. X minus x1 is point slope form. Now, this is one thing I did not review you in pre-calc. This is algebra 1, algebra 2 only. This is called point slope form of a line. It is the easiest version because what do I know G prime of 3 is actually? The slope. I've got the slope, check. The point is actually x1, y1, isn't it? What's the x1? 3. What's the y1? Oh,
17.
no, the y1, I have to go to my formula. 3, G prime is the slope of the tangent line. That's what we talked about from the very start, right? If I know the slope, I know the x value because they told us find at G prime of 3, right? How do I get a y value given an x value? Into the original function. What is 3 squared?
9.
Times 3 minus 3 plus 1. That was 25, wasn't it?
Yeah.
So, if I ask you for an equation, I don't care what the back of the book says. Write y minus the y1 equals slope, parentheses, x minus x1, and be happy with yourself. Free response, don't try to do y equals mx plus b. It literally is one extra step. Find the y value and do y minus y1 equals slope. If we want the calculus way, this is what it would be. This free response. If we're talking about the AP exam, do not try to go point slope form because you might make some simple multiply 3 by 17 wrong. If it was a multiple choice, well, then you'd have to do a little work and try to find the one that matches, right? The only ones I have not given you much help on are the radicals and the fractions. I would only say use a fancy form of one, and there's only like 2 or 3 problems anyway. So, your assignment is on Blackboard, finally.